Hello, welcome to this video, and today we're looking at this problem. Are there any whole number solutions to this equation? x1 minus x2 times x2 minus x3 times x3 minus x4 dot 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 x times x 2020 minus x 2021 times x 2021 minus x1 is equal to 2021 to the power of 2021. So, we can make a guess here. Usually in these, are there any whole number solutions? It will be very small solutions or no solutions. But here, there can't be any small solutions to give such a big number. So a guess would be that maybe there are no solutions. And that is correct. Let's prove that. So first things first, we'll notice that 2021 to the 2021 is an odd number. No matter how big it is an odd number. But then that will mean that maybe you can show that there are no solutions if one of these terms in the product is even. That it always has to be even if all of these x's are whole numbers. So we're going to wrongly assume that that never works. So assuming that each one of those terms is odd. So we'll have x1 minus x2 is odd, x2 minus x3 is odd, x3 minus x4 is odd, dot dot dot, x 2020 minus x 2021 is also odd, and then finally x 2021 minus x1 is also odd. So if we can show that somehow, if we can somehow show that this can never happen, that all of these are odd, that'll mean at least one of them will have to be even, meaning that the product is even, and we have a contradiction because this number is actually odd. And this can be done pretty easily. Notice that when we sum all of those, each number appears exactly once, and the negative version of that number also appears exactly once. So for example, negative x2 and x2. And then we'll have somewhere negative x3, and then there's supposed to be x3, negative x4 plus x4, and so on. So when we sum all of those up, it'll cancel with each other. And when we get to the end, we also have the negative versions of x 2021 and x1 that we had already at the start. So this cancels with this cancels with this will cancel something that should be there, so on, so on. This will cancel with something that should have been there. This cancels with this. So everything cancels, meaning that when we add all of those up, we get 0. But now, 0 is even. I'm not going to debate on whether it's even or odd, because it's even. But you can easily see that we have 2021 terms, simply because x1 is the first term, x2 is the start of the second term, and so on, so on. So x 2021 should be at the start of the 2021st term. So we have 2021 terms. So we have an odd number of terms, meaning that we get 0 is the sum of 2021 of odd numbers. So another odd, and so on. So again, 2021 odds. summing an odd number of odd numbers will give you an odd number. But that contradicts the fact that, like I said, 0 is even. I'm not going to debate about that. We have a contradiction. Then again, like I said, that finishes off our proof, because that means that one of these terms has to be even, meaning that their product is even, meaning that the sum can never be 2021 to the 2021 because it's odd. And that's it. A short, quick video. If you want to see more content like this, please subscribe to my channel. I'll be uploading more stuff like this in the future. Finally, that's it.